Hello, friends. Today I will tell you a story about how Soviet engineers decided to create a tank that practically flies above the ground. No, this is not science fiction or the delirium of a mad designer. In the early 60s, a hovercraft combat vehicle was indeed built in the Union of Soviet Socialist Republics. It hovered over swamps where ordinary tanks sank, rushed across deep snow, and, most incredibly, drove right across minefields, while the mines beneath it simply did not explode. The military was thrilled, and the engineers rejoiced. It seemed that a revolutionary solution for the army had been found. But why did this wonder tank never go into mass production? Why do only narrow specialists know about it today, and what exactly went wrong with the machine that promised to overturn tank building? The beginning of the 60s of the 20th century. The Cold War is gaining momentum, and the Soviet military leadership understands a simple truth. In the event of a major war in Europe, our tanks will face a serious problem. Central Europe is not the endless steppes near Kursk. It consists of dozens of rivers, hundreds of streams, and thousands of swamps and lakes. Every water obstacle can stop an offensive for several hours or even days, and time in war is everything. The amphibious tank PT-76, of course, knew how to overcome rivers, but it struggled helplessly and got stuck in swamps. It also moved with difficulty through deep snow, and minefields generally turned any offensive into a nightmare. Something fundamentally new was needed, something that could pass where ordinary equipment would get stuck forever. And so, in 1959, at the All-Russian Scientific Research Institute of Transport Engineering, known as VNII 100, an idea appears that sounds like pure science fiction. What if we create a tank that will not crawl on the ground, but glide over the surface on an air cushion? Imagine the reaction of the military when this was proposed to them. A combat vehicle that almost does not touch the ground. Are you serious? But the engineers at VNII 100 were as serious as ever. They were not suggesting making a tank that completely detaches from the ground. No, they were talking about a combined scheme. Ordinary tracks plus an air cushion that partially offloads the machine. The cushion was supposed to create such low pressure on the ground that the tank would literally glide over the surface. Hovercraft technology already existed by that time. It was used on amphibious vessels, but no one had ever tried to put it on a combat-tracked vehicle. This was an absolutely new path in tank building, a path into the unknown. The military leadership of the country approved the idea. After all, the Cold War required the boldest technical solutions. In 1959, VNII 100 received the task to begin research on the topic of a reconnaissance and airborne special combat vehicle on an air cushion. Which factory do you think was chosen to manufacture this piece of wonder technology? Correct. The legendary Chelyabinsk tractor plant. The very same tankograd that forged victory in the Great Patriotic War. The project received the secret designation Object 760. No beautiful names, no unnecessary information, strict secrecy. At the Chelyabinsk tractor plant, a separate group of designers and workers was allocated. They were to create something that did not yet exist in any army in the world, a tracked combat vehicle on an air cushion. The scale of ambition was grandiose. If the experiment succeeded, if Object 760 showed during tests what the engineers expected, it could change the entire concept of using light armored vehicles. Combat vehicles that pass through swamps as if on asphalt, glide over deep snow without falling through, and, most importantly, do not blow up on mines because the ground pressure is too low for detonation. It sounds like the dream of any tank division commander. Work began in 1960. Engineers at VNII 100 developed the theoretical base, made calculations, and designed the air cushion systems. The plant's designers were engaged in practical implementation. How to fit all this into the hull of a real combat vehicle. How to place the crew, armament, and engine while leaving room for powerful air blowers. By the spring of 1961, the project was ready. They began assembling the first, and as it later turned out, the only copy of Object 760, a machine destined to go down in history as one of the most unusual tanks of the Union of Soviet Socialist Republics. But first it had to be built, and most importantly, tested in real conditions. By the summer of 1961, a machine stood in the workshops of the Chelyabinsk tractor plant that was difficult to call an ordinary tank. Object 760 looked like a hybrid of combat equipment and some kind of fantastic apparatus from magazines about the future. The engineers created something truly unique. The basis of the design was a tracked chassis, 5 road wheels on each side, a rear drive sprocket and a front idler wheel. The suspension was individual torsion bar, standard for armored vehicles of that time. But between the tracks was located that very chamber-type air cushion that made Object 760 special. The air cushion was a flexible, strong skirt made of a special material that surrounded the bottom of the machine. Air was pumped into this skirt under pressure, creating a cushion between the machine and the ground. In partial offloading mode, the tracks maintained contact with the surface, but the pressure on the ground was reduced several times over. The machine, as it were, rose above the ground while remaining controllable. In the central part of the hull, between the fighting compartment and the engine transmission compartment, 2 air cushion blowers were placed, left and right. These were powerful units that had to constantly pump air under the machine, creating the necessary pressure. The sound of the working blowers was deafening, as if 2 giant vacuum cleaners were working nearby at maximum power. The layout of the machine was classic. In the bow section, there was a control compartment with a seat for the driver mechanic. In the middle part was the fighting compartment. In the rear part, the engine transmission compartment was placed with the engine and all systems. Everything was according to the classics of Soviet tank building. No revolutionary solutions in this regard. But the crew was placed in a completely unusual way. 3 people, the driver mechanic, the commander, and a 3rd crew member, sat under transparent semicircular caps. Yes, exactly. It looked like the cabin of a spaceship or a flying saucer from American movies about aliens. The transparent hemispheres rose above the hull, giving the crew an excellent view in all directions. Armament on Object 760 was installed for show. A mock-up of a 73mm smoothbore gun, 2A28 Grom, the very gun that would later be installed on the BMP-1. But on the test machine, it was precisely a mock-up and not a real weapon. The task was to check the very concept of movement on an air cushion, not the combat capabilities. The dimensions of the machine were compact. The length was about 7 meters, the width slightly more than 3 meters, and the height, taking into account the transparent domes for the crew, was about 2.5 meters. The combat weight was supposed to be approximately 14 tons, like the light amphibious tank PT-76. Outwardly, Object 760 indeed resembled something between a tank and a hovercraft. It had tracks like ordinary armored vehicles. The hull was angular and armored, also seemingly like a tank's, but those transparent crew domes, the protruding air blowers, and the flexible air cushion skirt all created a completely fantastic appearance. People who saw the machine for the first time could not understand if it was a tank, a hovercraft, or some kind of experimental apparatus for the moon. Only one external light headlight was installed on the machine on the right in the bow of the hull. Electrical equipment was minimal, only the most necessary. The machine was created as a running mock-up for testing, not as a full-fledged combat unit. When the assembly was completed and Object 760 was started for the first time, the sound was incredible. The working engine plus 2 roaring blowers created such noise that it was impossible to talk near the machine. Air rushed under the skirt with a deafening howl. The machine rose slightly, and the tracks began to rotate as if not feeling the weight of 14 tons of steel and armor. The first road tests at the factory proving ground showed that the machine really worked. Object 760 moved over the ground with noticeably less effort than an ordinary tank of the same mass. Passability was impressive even in the first tests, but the real trials were still ahead. Object 760 was expected in real conditions, in swamps, in snow, and on water. And this is where the machine had to show what it was capable of. 1961. Object 760 goes for state trials. Ahead are 3 years of the harshest checks in conditions that would turn an ordinary tank into a pile of useless metal. Wet peat bogs, deep snow, and water obstacles. This is the arena where this machine had to prove its right to exist. The first test is a swamp. Not just damp soil, but a real wet peat bog where any ordinary equipment sinks up to the turret. Object 760 is started, the air cushion blowers are turned on, and the machine literally glides over the surface. The tracks barely touch the ground. The main load falls on the air cushion. Where the mass-produced PT-76 hopelessly bogs down and stops, Object 760 passes as if nothing happened. Military observers do not believe their eyes. A machine weighing 14 tons goes across a swamp where a person would sink up to their knees. The ground pressure is so low that the peat is not even pressed down. The air cushion works exactly as the engineers calculated. It partially offloads the machine, allowing it to pass through inaccessible areas. The next test is deep snow. Winter, deep, loose snow, 1.5 meters thick. The PT-76 tries to pass and gets stuck after the first 10 meters. The tracks bury themselves in the snow, the machine sits on its belly, and from there, it only moves on a toe. Now they release Object 760. The blowers start working. The machine rises on the air cushion and begins to move. The snow beneath it is blown away by a powerful stream of air. The track finds support, and the machine moves slowly but surely. The speed, of course, drops compared to hard ground, but the machine moves where other equipment is helpless. The passability is simply fantastic. The testers did not expect this even in their most optimistic forecasts. On the water, Object 760 also felt great. The air cushion provided additional buoyancy. The machine held confidently on the surface and moved using its tracks like an ordinary amphibious tank. The speed on the water was decent, and the maneuverability was good. In this indicator, the machine was not inferior to the PT-76. The maximum speed on a hard road was 45 kilometers per hour. For a light tank of the early 60s, this was a very decent indicator. Maneuverability was also impressive. The machine turned easily, gained speed quickly, and obeyed the control levers. And then came the moment of truth. The trial on a minefield. This is where the main advantage of the air cushion was supposed to manifest itself. The military specifically prepared a section densely packed with practice anti-tank mines. An ordinary tank on such a field is doomed. The very first mine will tear the track or pierce the bottom. Object 760, with the air cushion working, slowly enters the minefield. The tension among all the observers is off the charts. The machine moves. There are mines beneath it. The pressure of the air cushion is distributed over a huge area. And what the calculations predicted, but what was hard to believe, happens. The anti-tank mines do not go off at all. The pressure is too low for detonation. The machine passes the entire minefield and comes out on the other side, whole and unharmed. Not a single explosion, not a single triggered mine. The military is in shock. The engineers rejoice. This is a revolution in tank building, a combat vehicle that can pass through minefields without blowing up. True, anti-personnel mines sometimes went off under the tracks, but this was not a problem. An anti-personnel mine cannot seriously damage a 14-ton armored vehicle, at most a small dent on the track. But complete invulnerability to anti-tank mines, that is a real breakthrough. Based on the results of 3 years of testing from 1961 to 1963, a detailed report was compiled. Object 760 showed characteristics of passability and maneuverability significantly surpassing the mass-produced PT-76. The machine passed where the PT-76 could not even begin to move. It seemed that an ideal solution had been found for reconnaissance and airborne units. A light, fast machine that would go everywhere and was not afraid of mines. Based on the test results, VNII-100 began to develop a project for a mass-produced machine. The project received the designation BRDMVP, or Object 761, an armored reconnaissance and patrol vehicle on a chamber-type air cushion. They planned to install real armament, improve the armor, and refine all systems. The military was already rubbing their hands in anticipation of receiving unique equipment, but then problems began. The very problems that eventually killed the entire project. Problem number 1 appeared immediately during the first tests, but its full scale became clear only after long-term operation. The fuel consumption of Object 760 was simply monstrous. 2 powerful air cushion blowers ate fuel at such a rate that the cruising range of the machine turned out to be catastrophically small. An ordinary PT-76 tank could travel about 250 kilometers on one tank on the highway. Object 760, with the air cushion working, barely made it to 100 kilometers. And yet, the air cushion could not simply be turned off to drive on tracks alone. Then the whole point of the machine was lost. Without the air cushion, it was just a very strange and uncomfortable tank with transparent domes. The military quickly calculated what this meant in practice. A reconnaissance machine that must go far behind enemy lines cannot afford a range of 100 kilometers. This is ridiculous. You drive 50 kilometers, turn around, and go back. The fuel is gone. And if you consider that on off-road terrain the consumption is even higher, then the real radius of action was reduced to quite miserable figures. Engineers tried to increase the fuel tanks, but then the machine became heavier, which meant the blowers had to work even harder, which again increased fuel consumption. A circular trap from which there was no way out. The designers struggled with this task but found no fundamental solution. The second trouble was no less serious. The flexible air cushion skirt turned out to be extremely vulnerable to any damage. A sharp stone, a protruding stump, a piece of metal, even a large branch, all this could tear the rubber skirt. And a torn skirt meant the air cushion stopped working. During the tests, the skirt was torn constantly. They drove through the woods, caught it on a stump, and tore it. They passed a stony section and hit a sharp boulder, a tear. They overcame a blockage of fallen trees, and the branches ripped the skirt in several places. Each time, the machine was transformed from a super-passable wonder of technology into an ordinary, clumsy tank. Repairing the skirt in field conditions was difficult and time-consuming. Special materials were needed, glue and time for drying. In a combat situation, this is unrealistic. It turned out that a single hit by a shell fragment in the skirt disabled the entire air cushion system, and there are plenty of fragments on the battlefield. They tried to make the skirt out of stronger materials. It became heavy and stiff and worked worse. They made it multi-layered, which increased the weight of the machine, and again fuel consumption grew. They protected it with armor screens, and the machine turned into an awkward monster. There was no ideal solution. The third scourge was noise. The working air cushion blowers roared so much that the machine could be heard several kilometers away. Stealth had to be forgotten forever. A reconnaissance machine that yells across the whole forest like a jet plane is nonsense. The enemy would hear it long before it reconnoitered anything. Sound insulation helped little. The noise source was too powerful. Engineers tried to make the blowers quieter, but then the power of the air cushion dropped, and the machine lost its main feature, passability. Another dead end. The fourth disadvantage was the complexity of the design and maintenance. Object 760 was stuffed with complex systems that required qualified care. Air blowers, the air cushion control system, special valves, and pressure sensors, all this had to be regularly checked, adjusted, and repaired. An ordinary tanker would not be able to handle such technology. Specially trained mechanics, a bunch of spare parts, and special diagnostic equipment were needed. In field conditions, maintaining such a machine was a nightmare. And yet, military equipment must be as simple and reliable as possible. A soldier is not an engineer. He has no time to understand the intricacies of air cushion operation. The fifth surprise came to light when they tried to install real combat weapons on the machine instead of a mock-up. The recoil from firing the 73mm gun created such vibration that the air cushion momentarily lost pressure. The machine would sag and then rise again. Shooting on the move turned into a lottery. Shooting was possible only from a stationary position with the air cushion turned off. But then the whole advantage of the design was lost. It turned out that the combat effectiveness of the machine dropped sharply precisely at the moment of battle. It was absurd. By 1963, it became finally clear. The concept of a tank on an air cushion, in the form in which it was implemented in Object 760, had no future. Yes, the passability was fantastic. Yes, the protection from mines was unique, but the disadvantages outweighed the advantages. The military conducted a cold calculation. A machine with a range of 100 kilometers, with a vulnerable skirt, with deafening noise, with complex maintenance, and with difficulties when firing, does the Army need such equipment? The answer was obvious. No. Too many minuses, too little practical benefit, too expensive to produce and operate. The BRDMVP project, or Object 761, remained on paper. It was not made in metal. There was no point. All the same difficulties that Object 760 had would not have disappeared for the production machine. The designers understood that fundamentally new solutions, new materials, and new technologies were needed. And such technologies simply did not exist in the early 60s. The single copy of Object 760 was decommissioned after the completion of the trials. The unique machine that could drive over mines and pass through impassable swamps went to the scrap heap of history. The dream of a ghost tank gliding over the ground died without being born. If you like this story about the Soviet ghost tank, give it a like, write in the comments what other useless equipment you want me to tell you about, and subscribe to the channel. Here are only the most absurd military developments that never hit the mark.